This is Professor Pelton. This is part 1 of chapter 5, section 3. We're going to go through graphing of polynomials in a more in-depth fashion. So just to review, polynomial graphs are continuous and smooth. You're not going to have any corners, cusps, holes, or jumps, which you might have in other types of functions. Those cannot exist here. So if I look at these following functions, which one is an actual polynomial? And which one is not a polynomial. So this one is in fact a polynomial. None of the problems exist. It's nice and smooth and continuous. This one has a jump and a hole. So not a polynomial. It has a jump. It has a hole. Thus discontinuous. Okay, and this one is in fact a polynomial. Right, it's continuous, it's smooth. You can basically draw it without lifting your pen or pencil from the paper, essentially, right? All right, pause the video, try the student problems for yourself. Okay, are the following polynomials or not? So no, not a polynomial. Okay, you can't have corners or cusps, right? That's the problem. All right, so this one is a polynomial. It's continuous and smooth. And this one has a jump and a hole, so not a polynomial. Right? No jumps, no holes, and it's discontinuous. We have all of those problems basically. Okay, so let's go through and do some problems to review and go more in depth this time than the prior section. Okay, so basically zeros of the polynomials are the x-intercepts essentially, right? So basically with a function equals 0, you have x-intercepts. Okay, so we'll take this function here and set it equal to 0. So 0 equals x to the 6th minus 3x to the 4th plus 2x squared. So always look for common factors first. There's a common factor of x squared. So you have x to the 4th minus 3x squared plus 2. And then that can be factored using quad form factoring. Right? So it's x to the 4th, x squared, splitting 4, right? So it's x squared, right? Because there's a 1 there, so it's a 1 here and 1 there and the other one, but that doesn't matter. So 1 times 2 gives me 2, which is 1 times 2, and negative 1 times negative 2. Well, that's clearly the proper product, because we want to get negative 3 as the middle term, so negative 1 and minus 2. So that is the factored form, right? So x squared is 0, x squared minus 1 is 0, and x squared minus 2 is 0. So x equals plus or minus 0 when you square root. X squared equals 1, or x equals plus or minus 1 when you square root. X squared equals 2, or x equals plus or minus root 2. Keep the exact answer, don't do an estimate, right? Okay, so we have x-intercepts, right? So the zeros are the x-intercepts, right? So 0, 0. We have 1, 0, negative 1, 0, root 2, 0, and negative root 2, 0, right? We have y-intercept. Well, if I'm a y-intercept, then x is 0. Whoops. That should be a closed paren. X should be 0, right? So if I just plug that in, what do I get? Y equals 0 to the 6th power minus 3 times 0 to the 4th power plus 2 times 0 to the 2nd power. So y equals 0. So that kind of makes sense. The origin is both a y and an x-intercept. So 0, 0 is an intercept, 1, 0, negative 1, 0. Root 2 is like what, 1.4? So like right here and right here. Okay, so those are our intercepts. Now we just need the end behavior, correct? So end behavior. So all we need to look at for the end behavior is the highest or leading term, right? Which is 1x to the 6th power, right? We don't need to look at the rest. It's irrelevant for end behavior. So as x goes to negative infinity, then the function goes to what? And as x goes to positive infinity, what happens to the function? Well, in both cases, whether you put a positive or negative in there, to the sixth power gives you positive infinity, right? Because the 1 is not going to make a difference. So that is the end behavior. So in the x positive direction, the function is going to go up. In the x negative direction, the function is going to go up. Okay, so don't write this part, don't write this part, don't write this part. So if I just simply followed all the points here and went through like I'm supposed to, uh-oh, it didn't work out because I need to be going up here, correct? So something didn't work out properly. So let's analyze what that is essentially. So I'm going to erase all what I just did, and we'll start over. That's why I said don't write this. Okay. Well, it's a little bit different than last time in the prior section. So let's put our points again, 0, 0. We're going to put 1, 0, negative 1, 0, 1.4, negative 1.4, and we'll put our end behavior. Again, you always draw the graph left to right like you read a book. Okay, so I'm going to go through this point, back up, back down. I'm going to bounce off this point, come back down, through, and up. So I don't know exactly how far up and down those loops go. Um, that's for calculus. But what I do know is it bounces off the 0 to accomplish this task. And the reason I know that is it's plus or minus 0, which means it happens twice, which is an even number of times. So if that happens, then it's not going to go through. It's going to bounce off the graph. That is the one minor difference that's going to happen in this section. Okay. All right, pause the video, try the student problem for yourself. Okay, so get the zeros of the graph or the x-intercepts. I'm going to set it equal to 0. So 0 equals negative x to the third plus 5x squared plus x minus 5. Well, they don't have everything in common, but the first two terms do. I'm going to factor out a negative x squared. So I'm left with x minus 5 plus x minus 5. Okay, so only the first two. This is the grouping method of factoring, right? So what I also notice is I can take out just a common 1 out of the second two, because you always want to put them into groups and see what they have in common. If they're prime, like the last one, they just have 1 in common. So they have an x minus 5 binomial in common between the two groups. So I'm going to factor out an x minus 5. So I'm going to be left with negative x squared plus 1. So that is the factored form. So x minus 5 is equal to 0, and negative x squared plus 1 is equal to 0. So x is equal to 5. And then negative x squared is equal to negative 1, or x squared is equal to 1, or x is equal to plus or minus 1 when I square root, right? So that means my x-intercepts are 5, 0, negative 1, 0, and 1, 0. And if I do my y-intercept, okay, so the function should only be 1. If I plug in 0 for my x, which is what it is by definition, it's also that's where it is on the graph, I get y equals negative 0 to the third plus 5 times 0 squared plus 0 minus 5. So I get a minus 5 because all those go to 0, right? Okay, so I'm going to go to 5, 1, 2, 3, 4, 5 on the graph, 1 on the graph, negative 1 on the graph, and then 1, 2, 3, 4, 5. So there are all my intercept points. Okay, so the next thing we need is the end behavior, right? So end behavior, which I only need to analyze the leading term to accomplish that task. In this case, that's negative 1x to the third, right? As the leading term. So as x goes to negative infinity, and as x goes to positive infinity, what happens to the actual function? Okay. Well, if I do negative infinity, the third power is still negative, times the negative is a positive. And if I do positive infinity to the third is positive, times the negative is a negative. So it's actually counterintuitive because the negative one switches the directions. So in the positive, in the positive direction I go negative, in the negative direction I go positive. So that is my end behavior. Okay, so if I go through the points this time, I'm going to go probably, let's move it over to here actually. Go through this one, down through, up, and back down. As to how far up and down each of those go, who knows? And notice I didn't bounce off at any time because none of my answers repeated themselves. The 5, the -1, and the 1 did not repeat. So therefore, you go through the point and you do not bounce off. That is the end of part 1.